So you might just have a calculator handy there as well, because I don't have the solution to this done out, or somebody might, just as we're going down through it. So this is the iron tablet one. So if you remember back to when we did this at the start of 6th year, you got a certain amount of iron tablets. I think we use 5 as well. So if you nearly visually think about what you need to do, you have 5 tablets that you crushed up, you put into a beaker, you added dilute sulfuric acid, and then you made it up into a volumetric flask. This is a 250 flask, I think, that we used. And then you use 25 mils of that every time in your titration. And they said at the beginning, your iron tablets, you must have a mass for it somewhere here. Did I snip that out? I did. Does anyone have 2009 on there? Just tell me what mass the tablets were in total. Oh, it's not on it. Sorry, I just pause this for a second and just have a look. 2009. Each one was 0.25 grams. So,
Excuse me, I just.
no hassle. 5 grams each.
Sorry.
You're alright, miss, no hassle at all. So this year you were told the weight of each individual tablet. Another year this came up, you were told the combined weight. So you might have been told to combine the 5 tablets weighed 1.5 grams. So that way you can easily work out how much an individual one is. So when you're working out, or the bottom line is, you want to work out how strong the concentration of this solution was. You're trying to work out how much iron is in this flask, and then you're working out of a tablet what percentage of it is iron, pure iron. So the start of the titration is kind of the same as always. You have your burette and you have your conical flask. When you're working with your titration figures, whatever else is over here is relevant, but when you're using or doing your calculation, it's the quantity that you use up here versus whatever quantity down here neutralizes it. So they're the ones that are relevant when you're using your balanced equation. So we look and see, we're working with iron and we're working with potassium permanganate, so let's put everything together. So we have, we'll put everything to do with iron over here, and put everything to do with potassium permanganate over here. So do I know in the titration how much of my iron I used each time? And I do. The iron was down here, Fe, and the permanganate, the MnO4 minus was up there. So how much of the iron was I using every time? You were using 25 centimeters cubed. Do I know the molarity of the iron? No, that's all the questions are related to that, so I'll put a question mark beside that. Do I know the volume of the potassium permanganate? Yeah, 18.75. Do I know the molarity of the permanganate? 0.01 molar. Straight away, from all we've done so far, titrations, which one do I know enough information about to start with? Permanganate. It's the only one I know something about, so let's work with that. So I'm working out the number of moles that I used. So the number of moles is equal to the volume in litres multiplied by the molarity in moles per litre. Therefore the moles is equal to, convert that to litres, that would be a litre. This would be 100 centimeters cubed, this would be 10, this would be 8, this would be 0.7, and this would be 0.05. So just do the check if you need to. So that's a litre, that's 100 mils, that's 10 mils, so that matches up. That's your litres. Multiplied by the molarity is 0.01 mole per litre. So therefore the number of moles is equal to, let me shout an answer to that.
1.875 by 10 to the power of -4.
Thanks, Ava. Moles. So what does that mean? That means that up here, sorry, down here, in your iron, you had 1.875 by 10 to the power of -4 moles. That's all good and well, but sorry, that's my permanganate. That's up here. So that's all good and well how many moles I have up here, but my unknown is the iron. So how do I equate how many moles of this I have to the unknown, which is all about the iron? Balanced equation. So for every one of these, you get 5 of those. So percentage wise or ratio wise, what will I have to do with this number to figure out how much iron I have? Multiply by 5, exactly, because you have 5 times more iron. So we squeeze it here. Therefore, we have 5 times more Fe. So we have 1.875 by 10 to the power minus 4, all multiplied by 2. That'll be what? 3.7 something. Oh, sorry, that's by 2. Needs to be by 5. Does anybody have?
9.375 by 10 to the power minus 4.
Oh, I'm doing 2. Go again, Keane.
9.375 by 10 to the power minus
4 moles of, what am I working with there? Fe. And not only that, what quantity was that found in? In how much? 25 mils. 25 centimeters cubed. You all following that so far? What's the first question asking you for? What's the molarity of your iron in general? Molarity? No problem at all. Molarity is measured in what? Moles per litre. So moles in 1,000 centimeters cubed. So, what do I do here? Divide by 25 and multiply by 1,000. 2 steps. Somebody just pop that into the calculator there and tell me what that equals. You can do it 2 individual steps, or let's just put it all in together. In the exam I do that as 2 separate steps. Dividing by 25 gives you 1 centimeter cube, multiplying that by 1,000 gives you 1,000. 0.0375 moles per litre. Part 1 done. Next one is the total mass of iron in 250 centimeters cubed. That's moles per litre. What are they asking me to get to? Mass per 250. Another way of saying that is grams in 250. It's like on Google Maps. Where you are, where you need to get to, there's 2 steps involved. I can't go straight from that to that. I have to do 2 little things, or 2 different steps. What's my conversion going to be? You can do either one first. Divide by, yeah. So if let's say we go from moles per litre to grams per litre. Grams in 1,000. So I need to multiply by the RMM. And then I have grams per litre. How am I going to go from grams per litre to grams per 250? Divide by 4. So your 2 steps are multiply by the RMM and divide by 4. Does it matter if you do it in the other order? No. Same answer will come out. The RMM of iron, which is equal to 56. So when you multiply 0.0375 by 56, 2.1. 2.1 grams in 1,000, and then I need to divide that by 4, so it'll be 0.525. So in total, in your flask, which is over here, you had 0.525 grams of Fe in total. That's that part there. Last part says, if you had a tablet, one single tablet, what percentage of that tablet is made up of iron? A couple of things to keep in mind. That's how much iron you had in your flask in total, but what did I do at the beginning? You put in 5 tablets. So what do you think would be the first and important step that you're going to do? You're going to work out of all of the iron in the flask, if I divide that by 5, that will tell me how much iron is in a tablet. So therefore, it's 0.525 0.525 divided by 5 will equal 0.105 grams in a tablet. What do I need to do now? That's how many grams of iron you have in one tablet. That's how heavy a tablet is. What do you need to do? Put that over. So, therefore, percentage iron is equal to 0.105 grams divided by 0.325. Multiply that by 100 over 1.
That's 2.3%.
32.3%. So what's going on, or what's different about this one? Start is the exact same. Work with what you know, get your numbers of moles, use your balanced equation to flip it over to the one that we're trying to figure out. That's moles per, then convert it to moles per litre by doing our normal steps. You're trying to get to grams per litre and then grams to 250, in other words what we had in our flask. Then you should know how much iron you have. This will change depending on the question. So be careful, and if you need to do a little sketch at the start, just so you know what you're working with. I said that another year they gave you the total mass of the iron tablets. Okay, so they told you, would say that the 5 together weighed 1.5. So you'd have another step there. You have to divide that answer by 5 to figure out what's in one tablet. So work with the figures you're given. If you think a little sketch is going to help, by all means do that as well before you start. And then you're eventually getting down to, in one tablet, what percentage is pure iron. Is that alright? As I said, it is due up. I think I went through some of the other theory parts on it.